Amazing. So welcome everybody to Farcaster Agentic Bootcamp. Here Limone.it from Urbe and Builders Garden. And we're hosting this bootcamp to showcase and learn all together how to build agents on Farcaster. Today is the last session about multi-agent system with Cassie. And I'm very excited about it. I think it's the best way to close these 2 weeks we had. It's been very progressive in terms of like complexity and topics we've been talking about in this session. So I think it's this session, in my opinion, will be one of the most like core ones, putting together many of the concepts that we've seen. I didn't check any slides or things that Cassie prepared, but I'm sure about it. And just a reminder that the hackathon is still going on. This weekend, I will also create check-in form for you all to submit. So it's a first check-in submission to see where you're all at, understanding who's building what, so that it's easier also to support you all. So I will release more information about it later today or tomorrow. And then hopefully next week we can reconnect again and do some early feedback session and whatever. That said, Cassie is already in the room, so please, Cassie, join us on stage. Feel free to share your screen, slides, anything. Let's get it started. Thank you for joining us, by the way.
Yeah, absolutely. Let me go ahead and see if I can do this right. I swear I get this wrong no matter what platform I use, but I'll try and share my screen and hope everything works.
Awesome.
Okay, I think the screen is being shared. Is that right?
Yes, we can see that.
Cool.
Perfect.
Cool. So yeah, today we're going to talk about multi-agent systems and open coordination. Just a couple of quick disclosures. We're currently working off Australia time, and it is 2 a.m. under that, so bear with me. I'm a bit tired. Hi, I'm Cassie Hart. Most of you know me, and if you don't, I'm the founder of Equilibrium. I used to be on the dev team at Merkle before the acquisition, and I've built a lot of fun things on Farcaster. I have built a lot of the things of Farcaster that people know and love, and obviously I've stuck around despite the grand transfer of assets, if you will. Today, our talk is going to be actually more of it's going to be a technical talk, but it's actually going to be a little bit more informal, if you will, about how you can actually coordinate multi-agent systems. Because we've already gone through the various ways in which people will actually run agents on Farcaster, and it wouldn't be useful for everyone's time to talk about the things that have already been done. There's plenty of resources for it and plenty of code examples. So I'm going to dive into the kind of the philosophy and the engineering mindset. So the goals for today are going to be talking about agent personas that feel real, how to make them feel real, how to coordinate them in an organic way, choosing the right interaction models for the type of interactions you're wanting to do with your agents, how you actually go about designing this system. It's not going to be like a formal system design exercise, to be clear. I'm not busting out Excalidraw this time. And of course, how to do all this and not go broke, because AI is pretty expensive, and if you do things the wrong way, you'll spend a lot of money in credits. So first of all, I'm sure this has been brought up a few times, but I'm going to have to say it myself. Why Farcaster? It's a permissionless network, and that's a really powerful tool, because a lot of the other ones out there, they may act like they're beacons of free speech and that they're open for anyone to build on them. But the reality is, the moment you start to get too far out of whatever their poorly defined lines are, they'll either shut you down, they'll demand you pay for some kind of expensive access, like what happened with Eliza. And it just ultimately ends up being not a great experience to actually build things, to just do things. The other thing is that identity is programmable, and that's actually a really powerful construct, because when you're trying to, create an account on other platforms, oftentimes they demand that you identify the the account as a user, or you get an API key and then it's a bot and everyone knows it's a bot. Obviously, a lot of people put work into faking it on normal accounts, but nevertheless, like with Farcaster, identity is just programmable. It's programmable for everyone, whether you're a human or an agent, which means that bots are welcome, even if sometimes misunderstood. And there's also cool people here. I've met so many like astoundingly cool people on Farcaster that I have not found anywhere else. At least certainly didn't find them as easily. And of course, why not? Have you seen the other options? So talking about bots, we're well past the days of stochastic parrots, but we're definitely still in the days where, like, if you don't really like get things working right, you'll end up getting a lot of bot style replies that immediately like trigger people into being like, I don't want to interact with this. This thing's trash. Like it's just, I know that I'm talking to a bot. It feels like I'm going through a helpline on the phone and it's miserable. Good prompting helps, but context changes everything. And that's really important when you're actually designing these agents. So when you're trying to think about that, obviously, like the easiest thing people will do is just put a big prompt, toss it at the largest agent possible, and it'll give you, a blend of variety. It can handle everything, but they're crazy expensive. And so oftentimes it's a lot easier to just use the smaller model options like Haiku for Claude, or the smaller models like the mini models of ChatGPT. But an idea that often comes up, and I've seen it actually even recently with some of the lessons learned from the Clanker team, is, there's this idea of like use a big model to tell the small models what to do, so that you don't get billed for the big model every single call. Like you can kind of use it as a filter criteria instead of having to do all the work. But this is kind of a bad idea, because you can actually take it a simpler step. Like you can actually solve these problems with a decent architecture and decent prompting, and of course, decent code. So instead, let's work backwards from the problem that's being solved and try to reason about it from core principles. And all about this is how we talk. So when it comes to humanized agent prompting, the bad idea, like it's the simple idea, it works. You just use a webhook, you get the cast from the user that triggered the bot, and then you respond to it. That's all the context you get, and it tends to be pretty limited. A great example of how well this can work is like Bracky. Bracky will respond, used to respond to you based on what you said to it, but it doesn't have any context beforehand. Clanker, very similar. It doesn't have any context beforehand. It's just what you asked it to do. So give it some memories. And ultimately, you get a really simple equation out of it. The input is the event that triggered it, memory that it has potentially about individuals that it's interacted with, or just general memory, and then, of course, the actual persona. And then the output, of course, is a type of action that it can take. But the problem is of just like engineering it as a like simple input output, you get actions, is if you're not careful about how you do it, you end up with a really like deterministic response. And much like the way that humans see pictures of what looks kind of like people and it feels very uncanny valley, deterministic output is the uncanny valley of text. So instead, you provide the persona prompt, you have a scope to the memory, you have a action policy that's a bit more than just reply as a cast, you have certain constraints around posting, and then of course you have a dedicated interaction style for this particular event. And so taking this out to the nth degree, you have essentially dimensions to personas. You think about the tone, whether it's more formally leaning as the particular agent should be, or if it's more mimetic in reply. You think about domain expertise, like, is this agent supposed to be a, day trader, degenerate, or is this supposed to be something that's answering general questions or what have you? You also have to consider risk tolerance, and this kind of comes into play, especially when you're using censored models, as well as just generally being a good steward of a bot in replies. And then you also have to consider social behaviors. And then finally, the engagement style. Some examples of this and how this plays out, and that'll help kind of like level set and make you get a good understanding of what I mean by this, would be like a market analyst or a contrarian debater or a news curator, like a bot that summarizes the last day of Farcaster, or a news curator that's hooked into all the like global news sources and is giving a summary, or something like a builder / developer evangelist. You can kind of see this with the Nanar bot. It's kind of like a dev evangelist in reverse. Instead of telling people how to use things, it's actually more of a complaint handler bot that turns things into tickets. It also does kind of have a personality to it, but the optionality that exists is obviously quite broad. And of course, another example would be you. Modeling agents after other people is kind of like a spooky tradecraft and in getting it right, but we've actually seen some good examples recently on Farcaster. I feel terrible because I actually wrote this down and I have lost all the notes on that, so I don't remember the name of that mini app recently, but it was like was it Among Strangers or something like that? It was like a murder mystery kind of game, and those were kind of based on the actual casts from the users that were playing. And so when you're trying to cross the threshold into realism, you have to think about, what do real people do? And the reality is real humans are slow. And I don't mean slow like intellectually. I mean slow in terms of how quickly they respond. They usually have a life. They tend to get tired. And they also tend to give up. And they tend to forget things. And they also tend to get distracted. If you don't have any kind of simulation of these behaviors, it starts to fall apart. The facade becomes very clearly bot-like, and it becomes less of a compelling experience for whatever it is that you're trying to build. So if real people are all of these things, why be people? And the reality is we're humans. We still fear the dark. We fear those who don't do these things. Something that looks kind of like a human, that's super fast, doesn't have a life, never gets tired, never gives up, never forgets things, and never gets distracted, would be honestly a very terrifying human to meet. So how do people? They cooperate. They can compete. They can react, or they can maintain order. And when you think about those kinds of interaction models, they flow over into the ways in which some people interact on social media. And Farcaster is by no means an exception to that rule. People will sometimes build on top of ideas. They will contribute down the threads and keep generating new content, creating new casts, or they'll compete by just tearing down what anybody has to say. There's very combative people on Farcaster, and I'll admit sometimes I am that combative person. There's people who will primarily quote cast things. Sometimes they'll react to it with something that they say, or they will actually just quote cast with no context. And then, of course, there's the secret group chat guy. And yes, I know that I don't believe anybody in this call is that group chat guy, but there's definitely those group chat guys on Farcaster where they largely don't post content, but they coordinate people behind the scenes to react to things. And so from these, you can actually build up the interaction models. You have a thread starter and reply guy type. You have a just a reply guy type. You have a summarizer or an observer, sometimes witty or sometimes with no comments. And you have an orchestrator. And now the term orchestrator is going to mean two different things in here. It's going to mean either somebody who is like this, or it's going to be an architectural term. And I'm saying that just to simply separate the two. So structurally, when you're thinking about how these models work, there's important things to keep in mind. Of course, the data that you're feeding into these models has to be very small and concise, especially when you're using smaller models. And so we start with JSON. You have an agent identifier for it that uniquely identifies it. So when you're coordinating these things, you know how to actually pick them out. You have a basic persona prompt. You have the specific topics that they are interested in. You have some kind of activity budget, and I'll get into why that matters in a second. and then you have a cooldown, and then finally you have a priority wait. And so a lot of this, you'll note, isn't actually the prompt itself. It's some metadata that makes it very useful when you're actually trying to reason about these agents in a distributed systems context. And the reason that's helpful is because when you're selecting which agent to respond, you actually can get a multifaceted series of responses in any given context. And that can be a very powerful tool because you can essentially hook up a webhook to the entire like fire hose feed of Farcaster, or you can at least scope it down a bit, but nevertheless, you have something that you can actually feed into a pipeline. And so that comes down to topic matches. Like I said, the specific topics that particular agent persona cares about. You have semantic relevance, which there's some pretty good literature on how you can actually determine this, but I'm just kind of alighting over this for now because it's really just basically a simple scoring function in this context. You can consider the recency of that particular agent. You can consider how much budget is remaining for their actions. You can add some randomness noise, which again is important because otherwise you end up with very deterministic replies and it feels less human. And then finally, when you have that score together, you have that score together on all of your agents, and you just go ahead and apply softmax to it and select the top one. So when you're thinking about that budget term, obviously there's system constraints. You have to keep in mind that resources are limited for you. Most likely you don't have an infinite budget you can spend on any of these AI providers. There's global rate limits, both within your own system and global rate limits at the protocol level. The protocol for Farcaster actually has a rate limit for accounts. They can only post so often in a short time frame. There's per agent rate limits, which really matters when it comes to the Farcaster side of things. And then you also have the consideration of per thread limits. And that gets back around to what makes things seem human is that humans can get tired. Humans give up. And if you apply that same kind of consideration as part of the budget concerns of a given agent, that can contextualize their experience so that they're producing content that feels more authentic. Obviously, also a duplication check. It's important when you're running a distributed system that things, when it comes to assuring delivery, we have built-in duplication checks in Farcaster itself at the protocol level. But duplication checks, when you have a randomization process applied, means that you might actually have the event trigger twice, and you have to make sure that you're actually handling that appropriately. And I'll get into how that works out at the system design level in a moment. Also, you have to consider the content safety filters of the AI agents you're using, because if you hit the safety filter too many times, they'll ban you. And I note that that's unfun because the reality is that oftentimes it can be benign interactions that cause this. So you just really have to be careful. But at the same time, sometimes it's actually just fun to have a chaotic bot that's uncensored. Some context constraints to be concerned with. Is the agent already in the thread? Has there been similar responses posted recently? Has the conversation been closed? So contextually, humans understand when a conversation has ended pretty well. And when some people don't get the picture, people will give you a much clearer hint. But that's not always the case. And it can be really hard, especially for bots, to understand that because they just want to keep replying. There's actually a wide variety of people who have made TikToks and Reels and whatever the hell, YouTube Shorts, where they're talking to ChatGPT on the voice mode and just trying to close the conversation with them. And they just fail to do so because they want to reply. And so baking in this kind of semantic scoring, has the conversation been closed, you can actually get a pretty good idea of that, not just from the system constraints that you've imposed, but also from the shift in semantic behaviors. But ultimately, it comes down to some pretty simple statements. Rather than having to use, as I said before, don't use a large model to actually orchestrate these. You can do this with code. It's not too hard. So basically saying if the last post was in the within 90 seconds, don't reply. If the thread has similar casts, don't reply. If the budget's been used, don't reply. And so when you're trying to thread the prompt needle through, it comes out in the form of basically this: your persona name, here's your behavioral rules, maintain this tone, avoid redundancy, prioritize these topics, respond if only if the relevance is above the threshold, keep casts under 320 characters unless you have paid for Farcaster Pro or already on the Hypersnap fork. Those are important considerations. But then you also have to remind it it's part of a multi-agent system. Other agents may have responded. There may be considerations you have to make with respect to that. Don't assume exclusivity. Don't disclose you're part of a multi-agent system if you're wanting to keep the illusion alive. Don't break kayfabe, basically, for the pro wrestler fans out there. And so what this ultimately boils down to is how you actually supply that context. And so back to a basic JSON structure, you have the event that triggered it. If you're using Nanar or Hypersnap, the event model is identical. You've already seen it in previous demos. The thread context, however you wish to feed that in, it could be in the event model itself from the webhook. You may want to give additional thread context by fetching the whole thread. That can be extremely useful for actually giving thorough context. If you want to take it a step further, you can also include recent memory, which includes interactions that agent may have had with that user or may have had in like existing conversations on this topic. And then also very important to the agent itself is agent-specific memories. And why this matters is because each of these things are a different thread. The event came from the webhook. The thread context comes from the thread itself. The recent memory comes from the broader system memory. The agent memory is applicable to that specific agent. And then you have whatever variety of system signals you want to bake in, whether there's a trend that you wish to apply, whether or not that particular agent is currently active or you've disabled it. One reason that can really matter in terms of the realness in coordinating multi-agent systems, this kind of harkens back to some research I did back in 2016, before LLMs were even a thing. I was analyzing politics. In particular, I was analyzing political interference on social media. And one of the most obvious tells of bots beyond like fast replies, which fast replies weren't so good back then because obviously technology for chat bots was not great and it was rather slow. The biggest tell, other than IP if you had access to it, was the fact that they're always online. How can that be always online? And so setting a schedule for your bot by baking it essentially into a simple Boolean flag, like, are you alive right now or are you not, is actually really helpful. And so all that together, you have your context supplied to your engine, and then the engine is going to dispatch these individual messages to all of your agents. And then from there, you get the outputs from each of those agents. Something like a choice of action. Will they post a cast? Will they quote cast? Will they reply? Will they just like? Will they ignore entirely? And then content, of course, if it matters for the given context, to supply said content, and then give a confidence score based on the semantic viability of that reply, based on whether or not that agent made any sense to actually perform this action. And that's all you really need. From there, you can, again, apply softmax. And so getting into the actual system design level, when you're trying to reason about these things, obviously you have the Farcaster API provided through a variety of different sources. You have semantic memory, and that's where it gets a little tricky. Like I said earlier, there's a lot of different ways to do this, and there's a lot of papers that continue to get published around this. You could think of it simply as a vector DB if you want, but those are expensive. You could do something like take an LLM engine like Llama or something like what I've built like Claru and start to extract the raw liminal space and store those responses and then let that mediate your future responses. Or you can just use a good old-fashioned doc store because it's cheaper. For agent state, individually, you might want to store those things in Postgres if you need to do a lot of relational mapping, as in database relational mapping, or you could just apply it in Redis for a very fast cache response. Or again, you can just toss it in a doc store, because when you think about it, the faster the response is. That can be good for waiting, like waiting the individual replies from different agents. But if you have that extra latency before the decision is made, that actually gives you a little bit of an advantage in terms of the realism effect. And then finally, you have the orchestrator, which is responsible for actually choosing these things and making these decisions and sending these requests out to all the variety of agents that you have. And that would be potentially, one, initiated by webhook, of course, but two, sending these things out through a durable queue. Think like SQS, Kafka, whatever kind of like queuing library you prefer. Or if you're really wanting to go the Postgres route all the way, you can do the vector extension for Postgres. You can use just basic relational data for Postgres, and you can obviously use Postgres as a queue. There is actually an extension for that. And then finally, when you're performing the execution of that action, as in sending it to the actual underlying agent library, whether it's ChatGPT or whatever, or you're performing the finalized action and interacting with the Farcaster API to submit that message back, you'll need some kind of serverless function in order to run it. Previous examples have included Vercel, but like you could also take it to a little bit less simple of a level and either run a server to actually host these, or you can use Amazon Lambda. But the orchestrator is kind of the meat of the matter. It's going to have to handle things, and the basic flow, of course, is the event arrives. You take the event embeddings, you query semantic memory, and then under that query, you're querying per agent memory, global memory, and then you merge these results together to produce that lovely JSON doc that I showed earlier, sending them out over SQS to all of the given agents that should be active, unless you really just want them to tell you for you, in which case then you get the variety of results that come back. Recommend using durable queues. It can be a real pain in the butt if you get lossy queues. And then you take the ultimate results, rank them, and truncate, and then finally inject that into the finalized prompt. And so getting back to the realism topic and thinking about what do real people do, it should kind of like contextualize now why the design choices really matter, because you want to be slow. You want to look like the bot has a life beyond this singular message that it's contributing. You want the bot to get tired. You want them to give up, potentially forget things. That's actually kind of useful just for managing context size. And you sometimes actually need them to get distracted. And so, of course, getting back to the point, why be like people? Because that's honestly what people want to deal with. Whether or not they know it's a bot doesn't matter. The experience becomes far more enjoyable, more engaging, more interactive when they can at least suspend disbelief and talk to the bot. Or you can just lie and never claim that you're a bot at all. And so the big thing here to think about when you're actually choosing that architecture, like the architecture doesn't really change between those choices so much. Like the storage choices are a variety of options. The dispatch options are they're all kind of like homomorphic. You can choose between any of them, but the key here is don't go broke when you're doing this, because like I said at the beginning, it is really expensive and you can absolutely burn a hole in your wallet. But this is FarHack, so I understand that people are going to be making choices that relates to possible outcomes of the actual hackathon. So I understand, get your bag. And after you got your bag, go ahead and keep these options in mind. Nanar API can be $500 a month, or you can get HyperSnap for free. You could use Privy, and if you go past any common thresholds, it'll get too expensive to use, and you'll have to start forking over real cash. We have QKMS. If you want to use S3, you can, but the egress fees will eat you alive. Use QStorage. If you need to do dynamic queuing, you could use SQS, or you could use QQ. And finally, if you need to do execution of discrete functions, you could use Lambda, or you could use FFX. And of course, finally, if you're using Claude, ChatGPT, or whatever, you can use Claru. It's free. All right, so I'm going to open this up to any questions, and obviously after this, I'm going to share links to all these resources, how you can get onboarded. Like I said, it's just straight up free. These things are either free for any amount of use, or at least free up until far greater limits than what any of these other options will give you. That's the last amount of shill I'll do. All right.
Wow, thank you so much, Cassie. If anybody has question, please raise your hand or feel free to type in the chat. I have one to start, maybe. I was curious to know more about these services that you mentioned on the free side of things, like how can you provide, how are you able to provide these services for free or close to that?
Yeah, so I mean, I was not trying to shill too hard.
Yeah.
But yeah, Nanar API is just grossly overpriced. I'm gonna like, you know, shots fired here. Yes, it's grossly overpriced. It's ridiculous that anybody who makes a modestly successful mini app is now forced to pay $500 a month to access data that anyone can get for free. We run our own Hypersnap node, but Hypersnap is open source, just like Snapchain is. And if you turn on the API flags, which we actually turn on by default now, you'll literally get the entire Nanar API implementation for free. If you run a node, it's, you know, whatever the cost of running a node is. But like I said, we have ours open. It's freely available at any time. As far as the privy to QKMS gap is concerned, we do have a pricing model, but it's like essentially negligible. You can actually check the details on equilibrium.com/QConsole. You'll see the pricing details there. But basically, like when you think about Privy, it buckets you into how many wallets you can do before it starts costing you money. With QKMS, we saw that same phenomenon at Amazon. Amazon's KMS, basically the same thing. We're actually API compatible. Amazon's KMS is literally $1 per key per month, period. Doesn't matter how often you use it. It's $1 per key per month. Privy doesn't have quite so expensive pricing, but it is still actually pretty pricey when you start to scale out past, you know, 500 users. And QKMS is purely per request base. It's like bucketed into tens of thousands of actual signing events before there's any sort of like consideration. And it's actually very, very permissive. Like you get a lot of signing events per month before there would be any billing involved. Plus you can pay in crypto. As far as Q storage is concerned, users get 5 gigs of storage free. Yeah, I will be happy to share links after this. But I'll put it here at least, so that way you can see all the various stuff that we got in terms of source, and then you can also link you to QConsole where that stuff is available. Can't talk and type. That is my one terrible flaw. I cannot talk and type. But if you check out the GitHub org I just linked, you'll see literally all of the source to all of these things. Q storage, like I said, 5 gigs free, lets you host a static web page without any real issue or hesitation. It's basically on a CDN spread all over the world. You'll get basically the same kind of level of performance if you were to use GitHub Pages or if you were to use Vercel. It will be literally just as fast for a SPA. Yeah, Claro's there at that specific address. I should note that like the repo for Claro is it's not super complicated. Like we do make it pretty easy to stand up, and other folks have been hacking on it, and it's been pretty cool to see. But in terms of like operationalized APIs, you will find access to all of those things here. And it literally, like I said, you don't have to actually provide any identifiable information. You can sign up with a wallet. SQS and QQ, like QQ is rounding errors level of free once you go past the free tier itself. F of X itself is currently under a private beta, but just hit me up. I'll add you to the beta. And like I said, Claro is kind of its own beast. It's got a lot of crazy stuff under the hood. So if you're doing stuff like image classification, we support it. If you're doing custom training of new models yourself, we support it. and it runs on a CPU, by the way. So yeah, it's a lot of flexibility available to you. I just didn't want to like go super ham on shilling right now.
Yeah, no, I was really curious. So thank you for explaining all of that. There are some questions in the chat. So Alexander asking if you're coming to Farcon Rome.
I really wish I could. I really wish I could, but unfortunately, I know that a lot of folks that are not in the US are certainly still well aware of the state of affairs in this country. And especially like with respect to people like me, I straight up legally cannot obtain a passport right now. So I'm kind of stuck here.
Too bad. What what was still in beta? Zal is asking. I think.
Oh yeah, that was FFX. FFX is our Lambda equivalent. We've been trying to roll these things out as fast as possible, but we also want to be respectful of the fact that things can break, and we don't want people to necessarily jump on those things like wholeheartedly and then find out that they're not working. Can you run something like dspy in FFX to define the agent roles? I'm gonna be honest, I actually do not know what dspy is.
Me neither. Again, if you want to explain it better, if you want also talk, open the mic. Let's see.
Oh, it's called among the readers. I'll have to take a look at that. I've not seen that before. Well, I'll say off the bat, unless the LLM of choice is pluggable to an extensive degree, I see an other providers tab, but it looks like you have to provide the provider. So if that's the case, we don't have an open AI compatible endpoint yet. So if that's what you're asking about, in order to support dspy, we don't yet. In terms of API compatibility, we are aiming to get Claro's API compatible with OpenAI, compatible with Anthropic. I don't know if we'll actually get to the extent of making it compatible with Gemini. What languages can you run in FFX? Anything that runs on Linux, doesn't matter. It's very similar to the bare bones Linux execution model for Lambda, but you can use dedicated harnesses for Node.js, for C#, for God, I don't think we have the Golang one ready yet, but we're getting there. What about ducks? What about ducks?
Any other question, comments, ideas?
If you can use Mythos in the hackathon, hook me up.
Yeah, I share statuette feeling, by the way. Santi, go, please.
Hi, Cassandra.
Yeah, absolutely. I can get you guys the slides.
Hi, Cassandra. Thank you for the explanation. And I want to ask you there is an example of an agent that have the good qualities and also the qualities of the human that doesn't respond, sometimes get tired. Did you create an agent with those characteristics?
Yeah, I have historically through, again, this is actually emergent behavior of the orchestration model itself. Like when you start to apply those restrictions to it is when it starts to become more human. So it's actually more programming than it is prompting that leads to those human behaviors. The one exception I would say is the memory side of things, and that really is going to be bespoke no matter how you go about it.
Nice. Any other question? We still have some time. Can we get the transcription as well? Yes, statuette. We will get the recording, the transcription, and the slides on the Notion. So right after, later today.
My spouse gets on to me all the time that I talk like at 2x speed and that I need to slow down, and I try to be cognizant of it while I'm presenting, but I am notoriously a fast speaker.
Yeah, Alexander, maybe for the hackathon you can build that.
Funny you say that. I've actually toyed around with 11 Labs to try to see if I could do that, but I haven't found a very like successful result with it yet.
I was trying a new something that I saw yesterday on X. I think there's this Avatar V by Agent. So they record you in a video and then the voice, and then they are able to recreate easily. Like in 10 minutes, I was able to recreate a virtual twin for myself. Not perfect, but we're getting there.
Yeah, we're definitely getting there. I think that obviously the response times on like interactive voice models also has gone down quite a bit. I have a friend that I worked with at Coinbase who made I forget what it's called. I think it's interviewing.ai or something like that. But it basically does like a full-blown system design interview with you, and the conversational pace feels incredibly real, but the voice still feels incredibly fake. There's just not enough emotion behind the words. That just doesn't, again, uncanny valley.
All right. If there's not any other question or comment, we can wrap this up. I really enjoyed the presentation. Honestly, I have never considered like building agents personas in this depth, and the structure like incredibly detailed. So thank you so much again, Cassie, for sharing all of this with us. Again, today, unfortunately, is the last session of the Farcaster Agentic Bootcamp. The Telegram group is going to be still active for the next 10 days, 2 weeks. So I'm going to, where is it? I'm going to get the link in here as well. So in case somebody didn't join yet, we are using it to share all the resources, questions about the hackathon, about the bootcamp. So make sure to join that. That said, let's wrap it up. Thank you everybody for joining today. Thank you everybody for joining the full 2 weeks. It's been fun. I'm looking forward to see hopefully many of you in Rome. And yeah, we'll stay in touch for the hackathon. Enjoy your weekend.
Oh, I do want to give one last note real quick. Sorry.
Yes, go for it, please. Cassie.
Really, really important. Just a learned experience from that 2016 example I was talking about. If you're going to build multi-agent systems to look human, sound human, be like as human as possible, and try to evade all bot detection mechanisms, do not ever pilot them towards political interference campaigns, or you will absolutely get an FBI trail on you. Speaking from experience, don't do that.
Great tip to end the session. Thank you so much. Yeah, especially in the US, of course. All right. Thank you again. See you all soon. Ciao, ciao. Thank you, Cassie. Ciao.
Thanks. Bye.